Hi guys, I'm just waiting a couple of minutes more for the rest of the guys to join. Thank you for attending. We'll be about 5 minutes more. Thank you. Okay, guys. I think we'll just give it a couple of minutes more. It's 2 p.m. I think some of the guys might just be running a bit late. We'll give it 5 minutes more and then we'll start. Thank you. Okay, guys, I think it's time to start. Thank you for joining the webinar. My name is Daniel, and the webinar is hosted by Baker Baines, and we're going to be looking at inventing for the nest. So it's an introduction to uh, the nesting utilities inside of Product Design and Manufacturing Collection 2019. So it's the nesting utilities for just a bit of housekeeping before we start. You can raise your hand on the poll button there if you have any questions. We're going to be doing questions at the end of the webinar, so there's a chance for questions. However, if you've got questions that you want answered at the end, you can still type it in the questions chat box at the bottom. And without further ado, we shall start. Okay, so the agenda very quickly is we look at the introduction, and then we look at Inventor nesting. And then there's a comparison matrix between the Inventor nesting utilities and TrueNest, Autodesk TrueNest. We'll jump into a demo where we show two nice examples. One is straight off of Inventor sheet metal, where we look at the full workflow of the Inventor nesting utilities. And then the next example is slightly different. We use a bit of iLogic in it to show you what can be achieved with regards to getting flat patterns out much quicker using iLogic functions. And then we look at the nesting workflow, the ideal workflow. And then we've got some takeaways at the end, and then it's time for questions and answers. So just before we start, can everyone see the screen? If you can't, or you're having issues hearing me, please let me know now. I'll give you a second to type it in. If everything is fine, we can carry on. Okay, everything seems to be fine. Let's carry on. So the summary, the webinar, we focus on the 2019 release of Inventor Professional inside of the Product Design and Manufacturing Collection. And the really cool feature or really cool tool that's released in this 2019 release is the Inventor nesting utilities available in the 2019 Product Design and Manufacturing Collection. In here, we explore some of the key workflows within Inventor. As mentioned, we run some iLogic to create some flat patterns. And also we look at the full workflow from end to end, from a sheet metal design, taking that into the nesting utilities, doing some nesting with it, running some HSM CAM on it, look at using the functions available to us. Okay. So some of the learning objectives in here. By the end of the class, you'll be able to explore some of the sheet metal and nesting tools directly from Inventor. You'll learn about the iLogic tools that make automating flat patterns quite easily done, and also create a workflow that'll save you time when doing nesting. Let's get into it. So nesting utilities, smart little nest in there. But if we look at it, the basic workflow is your model. So from your Inventor model, you take it across into the nesting environment, you add some nest to it, put it into packaging, and then from there you take it into the CAM environment for cutting. So let's look at a brief history of it. In November 2017 at Autodesk University, Las Vegas, Autodesk announced the nesting utilities available, and this was more featured around a product called Autodesk TrueNest and Fusion 360. However, with some development and testing, beta testing, the utility preview was available at the end of Jan 2018, and this allowed you to actually test the functionality inside of the nesting utilities that was going to be launched and released. And then with the global launch in April this year, we found that the nesting utilities were available inside the Product Design and Manufacturing Collection 2019, and all it is the plugin that you plug into Inventor to access this nesting utilities. If we look at the process that we use, so we start off firstly with the assembly design from Inventor itself. In there, we find that you can do all your sheet metal work inside of it. Any flat packing that needs to be done that will happen inside the sheet metal Inventor sheet metal environment. And from there, we take it into the nesting utility inside of Inventor, so the Inventor nesting utility. Here we will do some toolpath calculations and we can set up the nesting. From there, it's going on to the post-processing side of it. So then we go onto the machining side. So we can do some cutting, punching, the assembly that we're going to be working off. And then from there, we can actually go in and produce it. So you'll find that when we jump into it just now, you'll see that we can take a pre-sheet metal part, or we could have a sheet metal design that we're working off taken directly into the nesting environment. So let's have a look between the differences between Autodesk TrueNest and the Inventor nesting utilities. Now, there is quite a bit of differences between the two, and this is a bit of a comparison matrix. If we look at it here, we find that Inventor integration, that's available in the nesting utilities in the collection and not available in TrueNest. So TrueNest will not directly integrate with it, but it will accept different file formats. We can import common CAD file formats inside of nesting as well as TrueNest. And you find that inside of the nesting utility, you can bring in IPT, IAM, and the IAM file needs to have one supported IPT file in it, as well as DXF files. Automating true shape nesting, that's available in both the collection utilities as well as the TrueNest. The nest editing, inside of the collection, it's still in development, so it is in the development roadmap for it to come to be available soon. The date is unsure, so we'll just have to keep an eye out for that. However, that's available in the Autodesk TrueNest. The nesting editing, again, is also in development inside of the utilities, but available in TrueNest. The Vault and the PDM integration, so product data management integration, it's on the utility side, it's still in development. However, TrueNest has integration to the data management tools. And if we look at the toolpath and CNC processing, so DXF export is available in the collection for the nesting, as well as TrueNest. And we find that the waterjet laser cutting and plasma cutters available for Inventor HSM in the Inventor nesting utilities, as well as being available in TrueNest directly. CNC controllers, again, the very same thing, available as HSM inside of the nesting utilities, available inside of TrueNest. And we've got things like punch, saw cutters, and ply cutters. That's not available in the utilities, so something to point out there, as well as automatic nesting optimization. Those functions and features are available inside of TrueNest itself, which is a separate application to the utilities itself. Also, if we look at the production management side of it, the inventory and the inventory tracking, is available inside of TrueNest and not inside of the collection. So we've got things like multiple machine profiles, scheduling, capacity planning, database, and ERP integration, automated lights on operation, that's all available inside of the TrueNest and not inside of the nesting utilities function. If we look at Autodesk TrueNest first, we find that what type of nesting are you doing? Are you planning? So it's a nice indication of how the tool will work for you. So inside of TrueNest, you can see that true shape nesting, profile cutters and punching, rectangular nesting, linear saws and shears, linear nesting, chop saws, as well as high volume nesting and stamping. That's all available for TrueNest itself. And if we look at the Inventor nesting side of it, we see that we've got its optimized manufacturing strategy, okay, for sheet metal to reduce material waste. And that's what it is basically for. So it's integrated tools within Inventor sheet metal parts and assemblies. They read in DXF, so you can bring in DXF files in there. You can nest on multiple sheets of some or varying dimensions. There's associativity between 3D model and the generated nest, so that's quite nice. What it means is if the model has to update or change, you find that in the nest there's associativity between it, so that updates and changes as well. Okay, the ability to export nest as a DXF or 3D model, that's directly available for you inside of the Inventor nesting, as well as toolpath and CNC generation using the HSM CAM workflow. So if you're familiar with HSM CAM, you'll find that the workflow from after nesting to the machining and cutting environment is the same workflow that you would use. And again, of course, automatic nest reports. That's available in the nesting utility. So I'm going to jump in next to the demo of it. And in here, you'll be able to see exactly how the tool works and how we can use it directly from Inventor. Okay, let's get this started. Okay, so we find here we've got an assembly, and you find that there's a cover in there, and the little bits that you're seeing inside of it is not sheet metal, but they're parts that we can bring in. Notice on the ribbon, on the browser, sorry, we've got the assembly in there. By right-clicking it, we can actually create a nest from it. We can choose the templates that we're going to work from. So in this case, we'll use the Imperial template. Bring that in. And notice that the material mapping comes up. So we've got to map the materials to what type of materials we're going to be using it. And all the source files come into it, as you can see there, and there's a translation taking place. And if you look at the browser tree on the left-hand side, you see that there's a nesting tab that opens up. It's busy calculating the nest at the moment, so it's update. So if you click on each one, you'll find that the nest geometric shapes comes up in there. We go and create a nest study. Let's extend this a bit. And we OK that. So it starts doing an update for us. Bring it across, and you'll see that we've got the nested study in there. So on each study, if we click on it, it takes us to the shape. And of course, this is predefined by us in our packaging or the sizes that we need to nest from. And it also gives us a program number as well. We've also got a report to look at. So let's look at this. We can go down. We can see the information, so the number of plates being used. There's a cost indicator as well that you can add in and set up as well. Let's look at the packaging. So yeah, this defines the size and form for the raw materials that we can work with. So we can change that here. Let's make it. You can change the size in here to 50. And we can OK that. Now in here, we can do a recalculation of it. We can mirror it or reorientate it to the best fit, flip it around, and rotate it 90 degrees, rotate 180, or rotate 270. So there's various options that we can choose in here. The shapes, set the deviations, 80 degrees, and the increments. Okay, that does the calculation, and you'll find that it actually nests it nicely for us, so it gets it done for us. If you look at the properties again, we can go down and you can see the nest efficiencies and the area as well in there. So next, we go back to the part, and let's have a look and see if something has to change on a part. How does it affect and how does it update? So we go in here, we'll cover up some of the holes, so do some direct editing to it. So delete the faces. Finish the edit, go back. There's one more. Okay, let's do the one more. So there's some edits that we're doing inside the model, and we will translate that into the nesting environment. As you can see, the edits are done. Hit save. So we save all our changes. Go back into it and notice that there's a calculation button in there. Let's start recalculating and regenerating it. And once this is done, notice that it updates here. So the properties update from the model onto the nest as well, which is great. And we can see the sheet, the setups. We can export this as well, or we can create it into a 3D model. Now notice that in the model here, this allows us to do the camming on it. So again, the HSM workflow is followed in this environment. So what we would do is we would go and now set up the cutting of the shapes. So we'll do our setup sheet first to orientate our axes. So which direction the tool's coming in at, pick our node points. And now we can go into the cutting environment. So 2D profile. Now what's nice about this is you can choose the type of cutting. So laser, plasma, or water jet. I'm going to do laser on this one. The geometry. So we select same plane face. Okay. So those of you who are familiar with HSM would understand this workflow a little better, and will be able to recognize this workflow. If we look at it, we can do a simulation to see the cutting of it. And of course, that can be optimized as well. The next example is based on using iLogic. So in this example, what we do is you can see an example of some furniture. And notice that it's just not, you don't have to just use it for metal components. If you're using nesting for furniture in the furniture environment, you can also make use of it. Now, in this example, what I'm going to do is we're going to look at looking at taking a nest, an assembly, creating some iLogic on it to create flat patterns, and then taking that into the nesting environment. So again, first we start off doing creating a shrink wrap of it. So we'll remove certain features that's not applicable to it. The solid bodies are there. And then we'll go and convert that into sheet metal. Set the defaults first. $16mm thickness. And we'll use the make command. And what this does is it makes components of our assembly, so single components after we've done shrink wrap on it. Can apply that and cancel. So if we look at the shrink wrap side of it here, you can see the solid bodies are in there. If we go into iLogic, we'll add a rule in, and we call it an unfold rule. I'm just going to type in some code. So the code is available. So if you guys want, you could let me know afterward, and we can make this code available. And notice what it does. We can go in and have a look at all of the flat patterns or flat bodies of each one. What this allows us to do is allows us to take this quite easily into the nesting environment. Wait for the code to run. And next is we go back into the modeling space. Again, right click on it and create nest. Again, choose this time we'll choose millimeter. And notice that the file format that you output from here is an inest format. So we'll choose the mapping on it. And the extraction process will start. If you pick up any errors, you can use the error log to determine what the errors were and go back and correct it. Once that's complete, okay that. And notice we've got our components brought in. We create a nesting study. And if we have a look at it, you can see the nesting study. We can look at the sheet. And we can export this or create a model in from here and take that into the CAM environment for cutting. Okay, so that brings us to the end of the very two short demos on it. So let's look at the nesting file format. So it creates a new file format for you. It's an inest format. So the supported formats from where you start. So it uses from your Inventor IPT or IAM, as you've seen there. File formats can be brought in. IPT, these must be sheet metal files containing flat patterns. iLogic code to generate flat patterns, including the data set. So you can see it in the data set there that we've used. In the IAM, they must reference one supported IPT file. Okay. DXF, if we look at DXF, most DXF files will work inside of it as long as they have a closed, they define a closed shape. And then the nesting utility files is .inest files, and you cannot save these files in any other format. So it needs to maintain that format that the inest format. If we look at the nesting workflow and some of the steps, so firstly we'll update the material library. Okay, so make sure the library is updated. We create a packaging to define the form. So again, packaging defines the size and form of the raw materials. And when we create nesting studies, we'll obviously need to select from a list of packaging types of materials that we're going to work off. The create side of it, the import. So CAD files and translate into shapes. You can bring in any CAD and bring that in. So it supports any CAD. If you've got files that's not IPT or IAM, if they're coming in a step, you can bring them in, import them into Inventor, and from there you could take them into the nesting environment to create the study. Next is the edit. So we edit the nesting properties for the shapes that we've had, and then we can go in and create the nesting study. So after setting up the nesting properties, we can create a nesting study. A nesting study, of course, contains a series of suggested nesting for manufacturing of the object that we're going to work off. And each nest is a set of shapes arranged on the sheet that we're gonna cut off. And finally, we've got the report that we can have a look and see the report of the nesting study that we've done. And we can also export this into other applications or generate a 3D model of it. Okay, if you look at the preparation side of it, so the customization you'll need there. So you'll have to customize for packaging and also the process material library that you're going to be working off. So there's a little bit of customization to happen there. It's actually not customization of any software as such, it's more customization of the study that you're going to be doing. And then we go into creating the nest, and you'll see there it will take in an Inventor file or a DXF file that you create. Or if you've imported a file using any CAD inside of Inventor, you could also perhaps use that as well. And then, of course, calculating the nest. Notice that these little on the browser tree, you'll find that the little ball comes up, or circular shapes with two arrows in them. That indicates the calculation of it, and you also have the ability to see the progress of the calculation. If we go into the next bit, editing a nest. Okay, in here we allowed to actually do orientation, rotation. As you've seen there, you can choose a deviation or increment of nest in the nest properties. And then if you right click on it, you've got the nest properties. And in here you can choose the quantity, material, and priority, or the shape orientation as well. And then for downstream information, so you've got the reporting function that comes out of it. You can export the nest, the nested data, as well as generate a 3D model of it. Okay, so that brings us to more or less the nesting functions and the utilities. Just an overview and introduction to it. If I look at the takeaways that we have from it, we notice that it's integrated. So it's integrated nesting tools within Inventor, sheet metal parts and assemblies. It's a continuous workflow. If we look at it from all the way from our design process, and we use HSM workflow for the machining or cutting off our components. Access, so what's important here, it's exclusively for product design and manufacturing collection subscribers. So if you're not on a collection, and nesting is something that you would be beneficial to you, it's advisable to get onto a collection. You can speak to us directly about that, and one of the guys will assist you with getting access to it. And Inventor nesting, something to note here, the Inventor nesting utilities is not Autodesk TrueNest. As you've seen from the comparison side of it, there are some differences between the two. Okay, and I'll leave it open up for questions. So if you have any questions, please type them in the chat box, and we can take it from there. All right. Yes, I see some guys have raised their hands. If your hand is raised, please type a message on the questions poll or the chat box, and if there's any questions, we can address them now. Okay, any questions? Alternatively, if you don't have any questions now, or if something comes up later on, you can always email me directly at Daniel@BakerBaines. It's DANEEL at BakerBaines, BAYNES.com. And I'll be glad to have a chat with you about it, or you could give us a ring at the office as well. Okay, so if there's no questions, I'd like to thank you for joining this webinar. It was more an introduction to the utilities, to see how it works, look at the workflow from Inventor to the HSM utilities, and then we could take it into using the nesting utilities, and then to the HSM workflow for creating a nest and cutting out the shapes. If there's any questions that you have later on, feel free to give us a shout or pop me an email, and I'll be glad to assist in any way that I can. Thank you very much for joining, and hope to see you soon for the next webinar.